Hello friends, you are watching Data Structures using C. All the videos are brought to you by Ankpro Training from Ankpro Technologies. So friends, in this class we are going to start a new type of data structure called linked list. If you are new to this video, please go and watch our previous videos, and also the programming in C playlist where we have explained the structures, pointers and everything consisting of all the basic C programming videos, because from now on we are going to learn the new concepts and new data structures, searchings and sortings, everything, right? So what is a linked list? So far we have learned two data structures in the C language. One is stack and another one is queue. So this is the third type of data structure that we are going to study in this video. So linked list, what's a linked list? Linked list is a linear dynamic data structure. It is linear because the elements are going to be stored in the sequential order. Dynamic because at any point of time we can add the nodes or we can delete the nodes from the list. So linked list is a list having links between every two nodes in it. A linked list is a set of nodes, collection of nodes, each node representing an element or an item in the list, and there is a link between each two nodes, every two nodes, right? From that we can access all the other nodes in the list. It is a collection of some nodes containing homogeneous elements. That means collection of elements of the same type. Each node in the list contains two parts, and remember, node represents a memory block, right? And each node contains two parts. One is the data part, another one is the pointer to next node. So there is two sections in a node. One contains the actual data and other contains the address to the next node, right? So let us understand this diagrammatically. So how a structure of a linked list and node looks like. So this is a simple node. This is how the memory representation can be seen. So this is a node. It has got two parts. One is data, another one is PTR, right? So PTR contains the address to the next node, address of the next node. So this is one more node in the list. This also has got the data part and the pointer, which has got the address of the next node. So here in the first node, this is called the first node of the list, and this is the second node of the list, right? So both are of same size. We cannot have nodes of different sizes. We can only have nodes of same size, right? So the pointer of the first node always contains the address of the second node, and the pointer in the second node contains the address of the third node. So likewise it goes. And the last node in the list contains null in place of pointer, representing itself as the last node in the list, right? So this is the fourth node is itself a last node in the list. That is why it's containing the null in the pointer. So by seeing this, we can conclude that this is the last node and there are no more nodes after this node, right? So how to access these nodes? How to get the address of the first node? Once we get the address of the first node, we can get the address of the second node, which is stored in this pointer. So likewise, we can access all the elements, all the nodes sequentially. So to access any node in the list, we must have the address of the first node. So there is a pointer called start pointer which stores the address of the first node, right? So this pointer always contains the address of the first node. So this is a normal pointer. We can call it as start pointer. At any point of time, it contains the address of first node. But when the list is empty, there are no nodes in the list, we can initialize this start pointer with null, right? If start is equal to null, you can say that list is empty. There is no node in the list, right? So once we updated this list, it is looks like something like this. So this is a node. The address of this node is 1000 and the data stored in this node is 10. And in place of pointer, it has got 1002, which is the address of the second node, right? So this node has got the address 1002 and it has got the data 20, and the address stored in this node is 1004, which is pointing to the next node. Likewise it goes, and in the last node contains the null in place of pointer, right? So the start contains 1000, which is the address of the first node, right? So once we get the content of the start node, we can access any node in the list. So this is called singly linked list because every node has got one data field and one address field, right? So this type of linked list is called single linked list or a simple linked list, and this is one of the types of linked list. There are four other types. I mean, there are total 4 types in the linked list, and singly linked list is one of them, right? Moving on. So the operations that we can perform on linked list are insertion, deletion, and traversal. I hope you know what is insertion and deletion. Traversal means visiting each and every node in the list only one time, right? Insertion insertion inserts an element into the list. It may be beginning or it may be at the end or anywhere in the list. Or deletion means we can delete any node in the list. It may be at the front end or at the rear end or anywhere in the list, right? Okay, so how to define a node? So this is the diagrammatic representation. This is a node and there is a start pointer which holds the address of this first node. So we are going to use the structure concept of C language to define this node, right? Struct node defines a node. It is going to define a structure with the name node, and this is going to contain data variable of type int representing this field and a link pointer of type struct node. So here link is a pointer variable. This is same as PTR. So link is representing the pointer part of the node. So PTR and link are same here. Link is a pointer of type struct node because every pointer should be the same type of which it is going to point to, right? So apart from this node, there are several other nodes in the list. So to point to the next node which is of the same type of this node, we must have a pointer of the same node, struct node. So you know that the pointer always points to the variable which is of the same type, right? So to point to the next node which is also a struct node, we must have a pointer of the type struct node, right? Okay, so there are 2 fields in the node, data and PTR, and there are 2 variables in the struct node, data and link, both representing these 2 fields. And this start pointer is here, struct node. This is also this is also of the type struct node because this is going to hold the address of this node. If this needs to hold the address of this node, this has to be of the type same as this one, right? So start represents start is a pointer. Initially it holds null. Before creation of this node, this start pointer holds null, right? So let us go and see what are the different operations on linked list. Insertion, we can perform insertion at the end or at the beginning or after any node, right? We can insert a node at the end or at the beginning or after any node, and we can delete a node. The last node, we can delete the first node or any node in the list, and we can easily traverse through the linked list. Okay, so let us understand the C code to create a node. right? Okay, so here we are going to define a function called createNode. So this is the function which is going to be the function to create a new node, and this is also of the type struct node because this is going to return the address of a node. So that is why this is also of the type struct node, neither int nor float, right? Okay. So we are going to define here I'm going to declare a local variable, local pointer variable n, and n holds the address of the newly created node. So to do that we are using the malloc function. If you don't know what is malloc function, please go and watch our C playlist where we have explained everything about memory management functions, right? So malloc of size of struct node will create a memory block of the size representing struct node. Size of struct node calculates the memory available for one structure, right? We have already defined the structure with the name node, and size of calculates the memory required for that structure and it returns that. So how many variables did we create in the structure? Just two, right? One is data and one is link. So data requires 2 bytes and struct node is of type struct node, or struct node link is of type struct node. It also requires 2 bytes, so total 4 bytes is required. So that is what size of returns here, size of 4 bytes. So malloc function will create a memory block of 4 bytes which is of the type again struct node, and this entire malloc function returns the address of the newly created node, which is ultimately stored in this pointer n, right? So now n has got the address of the newly created node. Let us assume this node as the newly created node. Currently there is no new pointer, right? So let us make this as not pointing to this node. There is no start pointer yet because there is one pointer which is n. So n is currently pointing to this node, right? Because this is newly created node. Okay. Return n, and we will return this n. Okay. So now we have returned this n to the calling function. Remember, the function which creates new node is createNode. Okay. So let us see the C code for insertion of data into the node. And there are two cases. First case is insertion of data into the first node, I mean in the newly created node. And the second case is insertion of data at the end of the list, I mean into the last node of the list. So there are two cases when we are going to insert the data into the node. Okay. So let us consider all that. What insert node? So this is the function name which is going to insert the data into the node. So there are two cases. One is insertion of the data in the first node. Another one is insertion of data at the last node, in the last node. Okay. So we have created two variables here, two pointer variables, temp and t. So those variables are here. Temp is also a pointer variable of type struct node, and t is also a pointer variable of type struct node. So both these pointer variables can now point to the newly created node. So we have not yet created any node. Okay. Temp equals to createNode. So here is the function call for creating a new node. Earlier we have already discussed this createNode function, and I also said this returns the address of the newly created node, which is ultimately stored in temp. Now this temp a temp pointer is currently pointing to the newly created node because this create node returned the address of the newly created node, right? So this is the status of our new linked list. So we'll ask the user to enter the element. So the user will enter some element, and that is going to be stored in address of temp arrow data. Temp arrow data means this part. So temp is a pointer variable. This is pointing to this node. Temp arrow data means this part, this variable, data variable. The data which is coming in will be stored here, right? Okay. Next, temp link equals to null, and we will make this pointer because this is the first node. We are considering this as the first node in the list, so we will assign the null element to this node. Okay, so now currently this first node has the null element in the pointer place, right? Next, so suppose we are defining the code for when the list is empty. Say if the list is empty, I mean if start is equal to null, this means list is empty. We have just created this much, right? We have to store the address of the newly created node to the start variable, right? So if start equals to null, this means there is only one node in the list. Let us store the content of temp into start. So the content of temp is address of the first node. Let us store this content here. So now the start variable is currently pointing to the newly created node after this statement, right? If this is true, this will happen. Say we have created the node, but this is not the first node. That means there is some address in the node, in the start node, right? So else when there are nodes in the list. So if this is not true, what happens? T will hold the content of start. Let us assume there is some address in the start. Okay, so T will hold the content of the start, right? So this will go here. So now T is pointing to some node in the list. So and we will iterate throughout the linked list until T of link not equals to null, and we will iterate through the linked list until T of link, the content of T, remains not equal to null. This means whenever we reach the null, whenever T points to the last node, while loop expires, while gets fail. So until then we will go and increment T pointer. So every time T gets T of link, every time it gets the new address, right? And whenever it reaches null, this will get expires and T will hold the address of the last node. If that is true, and then we will store the temp, content of temp, inside T arrow link. T arrow link means the last element, the last node in the list, right? So there we are going to store the content of temp, which means the address of this newly created node, right? So let us see the code to display the list, right? So let us assume this as the linked list that we have got. Void display function will display all the nodes in the list, right? So let us create a variable temporary pointer. So here we have created the temporary pointer of type struct node. If start equals to null, so if this contains null, there is no node in the list. List is empty. Else means the start has got some address in it, right? So in that case, we will store the content of start into T. That means the pointer, the address of the first node is stored in T, right? So T pointer now points to the first node in the list. So to display all the nodes, contents of all the nodes on the screen, we have to iterate from the first node to the last node, right? So whenever T reaches null, that means whenever the content of T remains not equal to null, put it in the loop and display T of data, display this thing, right? And increment T. So how we are incrementing T? Just putting the link of T again inside the T, right? So the link of t is this. Again we are putting back here. So now this is pointing this thing, right? So here t equals to null. So this case fails. So this will while will expire. So now while condition will fail, right? Okay. Now see the C code to delete a node. Okay. So obviously we will create a temporary node here. R is the temporary node. If start equals to null, so there is no node in the list. List is empty. You can't delete a node. Else R equals to start. So R will hold the address of start. That is indirectly R is pointing this node. Start equals to start link. Now start will hold the address stored in this link. That means it is indirectly pointing to this node, right? Free of R. So now we will free this R. That means if we free this R, this data, this node will be deleted and R start pointing to this node, right? So this is deletion at the front end, deleting the first node, right? So this code works for deleting the first node. So this is the entire program of the linked list. Let us run this program and check. So here is the main menu, which is telling 1 for add data to the list, 2 delete first node, 3 view list, and 4 exit. So let us view the list by pressing 3. List is empty. So let me add the nodes into the list. 1. Enter the element. Say 5. Again 1. Enter the element. Say 6. Enter the element 7. Right? Let us view the list. 5, 6, and 7. So there are three nodes in the list, right? So let us delete 2. Let us check. So 6 and 7. So the first node has been deleted, right? Let us delete one more item. View the list. So the second element has also been deleted, right? 4 for exit. So I hope you understood this program. Please write this program down on your book. Pause the video and start writing this program. So I will scroll down, pause the video and write the program. Well friends, that's it for the class. Subscribe to our channel on YouTube, like our page on Facebook, follow us on Twitter and join our group on LinkedIn. Thank you.